Dr. Sujit Sarkar from Purnaprajna Institute of Scientific Research, Bengaluru. The title of his talk is A Conformal Field Theory Study for Quantum Ising Model with Longer Range Interaction.
At first, I would like to express my deep gratitude or acknowledgement to the organizer, those who have given me chance to talk in this platform since 9 years I'm talking, and also acknowledgement to the Ramanujan Research Institute Library. Without their help, it's practically impossible to continue my research. Okay, now I go into the outline of the talk. It's an older version. That is this introduction. Okay, I would like to skip a few words of the Ising model. And when the Ising solved his Hamiltonian and not get the transition, he became so frustrated. In his office, he used to walk in that way. Up, he came down. Okay. So now I go to the motivation of the study is the following, and it is well known in the literature of the quantum Ising model, minimum CFT minimal. I will come to this point to describe the central charge behavior. Now the question is how to describe the central charge behavior for the quantum Ising model for the longer range interaction, or in other words, the quantum Ising model in presence of the spin cluster also, the model Hamiltonian and several gapless and also quantum critical line in presence and absence of the transverse field. And we raise the question, what is the relation between the central charge, quantum criticality, and the transverse field? The study, we raise this question whether there is any possibility of the quantum ellipsis transition in the quantum Ising model or in the other case of the extended quantum Ising model, and what is the similarity and the difference between any possibility of the conformal quantum criticality and the non-conformal quantum criticality. This is the main motivation of this study. Actually, it's an older version. This is the Hamiltonian after the Jordan-Wigner transformation. That is the basic Hamiltonian. This is nothing but the transverse field. This is nothing but the quantum Ising model, Ising interaction with the nearest ever. This is nothing but the spin cluster, or in other words, the longer range interactions. I can express above from that. I have expressed this is the in terms of the spinless harmonic chain. The model Hamiltonian after the Fourier transform, I can state in the terms of this. This is in the literature called the Anderson's spin Hamiltonian. And my quantum critical line is the 3 quantum critical line occurs for these values of the momentum. And the topological angle, I can define also the topological angle. I can also express the quantum Ising model and also the spin cluster Ising model in the Majorana-Farman representation. This is the Farman, spinless Farman. I recast in terms of the two Majorana-Farmans A and B indexing with the J site index. And at the end of the day, I can write my Hamiltonian in terms of this form. Or more explicit, I can write in this Hamiltonian in this form. And these are the one-to-one corresponding parametric relation. My main motivation is to express that is this Hamiltonian. I can map my Hamiltonian to the polynomial. And from that polynomial solution, I can extract the whole physical properties of the whole system. This is the one-to-one corresponding polynomial. And at the end of the day, I express my Hamiltonian as a complex function, aeromorphic function, analytical in the whole complex plane. And at the end of the day, I find the zeros of the solution. I will play that is the polynomial zeros of the solution to extract that. Okay, and now the question is this, I can also, that is this second nearest ever hopping and the extended, I can express the generalized eta chain when in terms of the Majorana-Farman representation of the quantum Ising model in this form. At the end of the day, I can express the polynomial in the form of the product of these. These are the zeros of the polynomial up to a global factor. Now the question is this, what is the conformal field theory? Okay, now I have running out of time. So the conformal field theory is a field theory of quantity. It is invariant under conformal group. A conformal group is a set of transformation of space-time that preserve the angle. Generally, a conformal transformation is a coordinate transformation. Its local scaling of the matrix. A field theory rotation, translation, scale invariance is said to be the conformal invariance. Fixed point theories such as a free boson or the free Farman theories are the conformal theory. I would like to solve this is the quantum Ising model with the extended range interaction. I can express in terms of many ways. If anyone can understand the mathematics in rigorous way that element physics can understand many physical system. Okay, now I go to this point. So I come to this point. This is the conformal transformation. Angle is the 90 degree. Is there, but this is not the conformal transformation angle is not is here. What is the central charge? Central charge is the degrees of freedom of the conformal field theory. Now I go to the, okay, now this is my main results. And these results, if you see lambda 1 for the nearest ever, lambda 2 is the second nearest ever coupling. It is in terms of, in the absence of the transverse field, but here in the case of in the presence of the transverse field, you see here is one quantum critical line, here is the other quantum critical line, here is the other three quantum critical line. Here is one multi-critical points. Here is the other multi-critical points. And this line is nothing but the quantumizing ordle or the transversizing ordle. Here for there is no transversizing ordle. So in this case here, the two quantum critical line. And you see here the central charge value at the quantum critical line is the half. Central charge value is the quantum critical line of here the central charge is the value, and W is nothing but the winding number. Winding number is nothing but the topological invariant number. At this point, the system has the CFT quantum critical conformal quantum critical point, but here there is no conformal quantum critical point due to there is no absence of the Lorentz invariance at this point. But in this case, when u equal to 0, at this point there are two quantum critical line, and this is the add up, and there is a no all quantum critical line at is having the Lorentz invariant. So the all criticality is here is the conformal quantum criticality. But in this case, this is the only one point where there is no conformal quantum criticality. Here z equal to 2. Z equal to 2, the system has the quantum if-switch point. Here there is in presence of the transverse field, there is the evidence of the quantum critical point, but in this case there is no evidence of the quantum if-switch point, and also the non-conformal field. Just only 1 minute. Okay, so I can express my unitary representation of the Virasoro algebra to find it in the detailed solution. So this is the plot how the weighted conformal weight central charge and the integer values of this going in that way. For C equal to half, which you have got, for the M equal to 3 here, and also the M equal to 4, 5, 6, C equal to 7 by 10, 4 by 10, 6 by 7. And this is that our formula to calculate the central charge for the higher longer range interaction, ordinal Hamiltonian, and these are the results which I have been already at you, and this is the dispersion for the transversizing model, and this is the dispersion of the longer range transversizing model for two quantum critical point. Here is the z equal to 1, z equal to 1, z equal to dynamical critical point. This is the if this transition is going on, and I have already told you explicitly detailed, and we have presented the results of conformal field theory study for quantum Ising model with longer range interaction in presence and absence of the transverse field. We have shown explicitly that central charge is 0 for the gap phase of the system, but finite for the gapless quantum critical line. The topological properties is the same for the quantum critical line without the transverse field, but it is different from the quantum critical line in presence of the transverse field. Okay, we have predicted the two different kind of multi-critical point. One is the conformal quantum critical point, and other is the non-conformal quantum critical point, and we have predicted the existence of the quantum if this transition point. Thank you for your kind attention. Any questions, comments, I'm ready to face.
Since there are no questions, let us thank the speaker.